Now, as you know, anything you can solve it using recognizing directly. We can use substitution method to solve it, and you represent the value of fx always. So now let's go to practice some questions for substitution. I said if you have product rule and any bracket, it will be substitution. Okay, I have some different questions like this. Here we have integral of 15x squared times cosine 5x cubed. Here I have two ways. The first way, using recognizing. Why? Because I have multiplication of two different functions. Here power 3, here is power 2. So we can solve that using recognizing. So let f of x is equal the inside function, which is 5x cubed. So f dash x is equal 3 times 5, it will be 15x squared. So I have the derivative of that function directly. The derivative of 5x cubed, it will be 15x squared, so that it will be rejected. And as you know, so the integral, it will be integral of cosine, it will be sine 5x cubed only. We didn't look for inside because the inside is not linear. All of that defined from 0 to 1, so it's equal. We just substitute now. It will be sine 5 times 1, it will be 5 minus sine 0. Then evaluate that on your calculator to get the final answer in 3 significant figures. That's one way to find the answer. That using recognizing. And I said if you solve using recognizing, you can solve using substitution. So let's go to show how to solve that using substitution. In substitution, we take u always the value of f of x, and you know that it looks in the form cosine fx respect to the x, so you must have here f prime of x, and always f prime is rejected, as you know. So the integral directly, it will be negative sine x. That rule's not given. That rule's not given in the exam. Only one rule from recognizing given, f prime over f. So you here represent the value of an fx, which is 5x cubed. Now implicit differentiation du, derivative of that 15x squared respect to the x. And we do implicit differentiation to state the value of the x in terms of u. It will be du over 15x squared. Now we're back to integrate. We substitute inside integral 15x squared, it's still cosine. We just substitute that inside by u, so that is u times, and also we substitute dx by its value, it's a du over 15x squared. And as we know, we do that to change the question from complicated variable to be in a simple variable. So 15x squared divided by 15x squared cancelled. So the question changed to be integral of cosine u respect to the u. And all of that with the limits. Don't forget that 0 to 1, 0 to 1. So the integral of cosine, it will be sine u, it's defined from 0 to 1. Now substitute u by its value, it will be sine. What is the value of u here? It will be 5x cubed, defined from 0 to 1. So I got the same expression here and here. So anything you can solve using recognizing, it's so easy to solve it using substitution. Also here, I have multiplication, product rule. One of them is e, but the function here is not standard. The function is not standard, so we can use substitution and we can check if you can use recognizing or not. So let's check first recognizing. So the function f of x here is given as x cubed plus 2. So f prime x is equal 3x squared. So since you have x squared here and x squared here, so you can use recognizing. How that? As you see, it will be integral of 5 as a constant, take out, x squared still here, times e to the power x cubed plus 2 respect to dx. So we know that the derivative is equal 3x squared. So we're missing 3. So we just multiply here by 3. And divide here by 3. So now all of this represent the derivative of denominator, of the power, sorry. So we just back to integrate. F prime always is rejected. It will be 5 over 3. Integral of e, just copy paste. All of that plus c. So if you got the answer using recognizing, you can find it using substitution also. Because sometimes he said that in the exam, using substitution method, find the answer of. So using substitution, what we have to do? First, we choose u, represent f of x. So it's always integral of e to the power f of x. So f of x here is x cubed plus 2. Implicit differentiation, du is equal 3x squared dx. Why? To state the value of dx, it's equal du over 3x squared. Now substitute in the integration, it will be equal integral 5x squared, it's still, time e, we substitute fx by u, time dx is equal du over 3x squared. So it's equal x squared here cancelled with x squared, take 5 over 3 outside, it's a constant, time integral of e to the power u respect to du, it's changed to be in standard rule, it will be 5 over 3 times e to the power u respect to d, or sorry, plus c. Now substitute u by its value, so 5 over 3 e to the power, the value of u, it will be x cubed plus 2. So I got the same answer, or I get the same answer using recognizing or substitution. So that question for all of you, just practice it. And the idea here, any bracket, you need to change that bracket first to be n, or any radical involving more than one term, change it to be in bracket form. It will be 1 plus x cubed, and here square root, it will be 1/2, and when we switch that from down to up, it will be negative. All of that respect to the x defined from 1 to 2. Sorry, the outside here x squared. Also, you can solve using both, using recognizing because that has second degree, and using substitution. So you can complete using any way as you like. Now we're going to talk about parts. What's the meaning of parts? In parts, we divide the function in two parts. Integral of u dv is equal to, we just do that, choose two functions, one is u and the other is called dv. U always the easiest in differentiation because we will differentiate it to take du, and v is the easiest of integration because we will integrate to get v. So here we integrate, and here we will differentiate. So the rule, it's u times v minus integral of v du. So it will be equal u times v minus integral للفي دي يو. So I have some steps to solve some questions here. Look at that question. He said find that integral or work out that integrals. First, I have multiplication of two different functions. I have here bracket but not raised to the power. So I have two functions here. One is called u and the other is called dv. Which one is easiest in differentiation here? U or dv? Here, one u and one dv. Which one is easiest in differentiation? I think that bracket. So I will take it 3x plus 2. And here, ex. Respect to the x. I will differentiate that. It will be du is equal derivative of 3x. It will be 3dx. I will integrate that. Integral of ex. It will be ex. So we follow the rule. It's equal u times v. It will be 3x. Keep it inside bracket. Times e to the power of x minus integral of v du, which is 3ex respected to the x. Now I have integral of a standard function. We just integrate it again. It will be 3x plus 2 e to the power of x minus integral of 3x. It will be 3x, all of that plus c. It's finished. So we use parts if you have multiplication of two different functions, but you need to notice some things here. First, if you have like that question, integral of x time, for example, cosine x dx, integral of x time cosine x dx, integral of cosine x time cosine x dx. According to the product of the functions here x times x, here x squared times x, here x times x squared. So we just compare between the degree of outside function and the inside function. If they are equal like that, here x to the power 1 and x to the power 1, so that is parts. And the parts here have it one time because the power here is 1. Like that question, it will be also parts. The degree here is greater than the degree inside. Degree here is 2, but here is 1. But if you have inside has power greater than outside, it will be substitution. Note that, and you always take the value of fx, which is x squared. Attention to that. If you have multiplication of two different functions, the outside function have degree equal the inside function, it's parts. Outside has power more than the inside by 2, by 1, like this is 2 and here is 1. Right? So it will be parts. If outside less than the inside, it's substitution, and you always equal the inside function.